Have you ever looked up at the night sky and just wondered, how did all of this begin? It's a question that has captivated humanity for millennia. Well, let's take a journey, a trip back in time to the very beginning of everything. Picture this: absolute nothingness, no space, no time, no matter, then, in an instant, an explosion of unimaginable energy, the Big Bang. About 13.8 billion years ago, our entire universe burst into existence from a point smaller than a single atom. In the first fractions of a second, the universe expanded faster than the speed of light, a process called inflation. It was a chaotic, incredibly hot soup of fundamental particles. As the universe expanded, it also cooled down. Protons and neutrons began to form. For about 380,000 years, the universe was still too hot for light to travel freely. It was like a thick, glowing fog. But then, as it cooled further, electrons combined with nuclei to form the first atoms, mostly hydrogen and helium. Suddenly, the universe became transparent. Light could finally shine. And this ancient light is something we can still detect today, known as the cosmic microwave background. For millions of years, the universe was mostly dark, filled with vast clouds of these simple gases. But gravity, the silent architect of the cosmos, was at work. It began to pull these clouds together. Denser clumps of gas started to form, spinning and heating up under their own immense weight. When the core of one of these clumps became hot and dense enough, a miracle happened. Nuclear fusion ignited. A star was born. These first stars were giants, hundreds of times more massive than our own sun. They burned fiercely and lived short, dramatic lives. Inside these stellar furnaces, something incredible was happening. The intense pressure and heat fused hydrogen and helium into heavier elements. Carbon, oxygen, nitrogen, the very building blocks of life. When these giant stars reached the end of their lives, they didn't just fade away. They exploded in spectacular supernovas, scattering these newly forged elements across the cosmos. This cosmic dust and gas, enriched with heavy elements, became the raw material for the next generation of stars and planets. Gravity once again worked its magic, pulling this enriched material into swirling disks. At the center of one such disk, about 4.6 billion years ago, a new star ignited. We call it the Sun. Around our young sun, the remaining dust and gas in the disk began to clump together. Tiny grains stuck to each other, growing into pebbles, 10 boulders, 10 planes, through countless collisions and mergers over millions of years. These bodies grew larger and larger, eventually forming the planets we know today: Mercury, Venus, Mars, Jupiter, and of course, our own home, Earth. Early Earth was a wild and violent place. It was a molten ball of rock, constantly bombarded by asteroids and comets. One of these impacts was so colossal, it is believed to have blasted a chunk of our planet into orbit, which eventually coalesced to form our moon. This constant bombardment also delivered a crucial ingredient: water, frozen inside comets and asteroids. Over hundreds of millions of years, Earth began to cool. A solid crust formed, and the water vapor in the atmosphere condensed and fell as rain for millennia, creating the first oceans. Our planet was now a water world, but it was still barren and lifeless. The stage was set, but the actors had not yet arrived. Then, somewhere in these warm, nutrient-rich primordial oceans, another miracle occurred. Around 4 billion years ago, simple chemical compounds, perhaps energized by lightning or deep-sea hydrothermal vents, organized themselves into the first self-replicating molecule. Life had begun. For billions of years, life remained simple, consisting of single-celled organisms like bacteria, but they were busy. Some of them, called cyanobacteria, developed a revolutionary new trick: photosynthesis. They learned to use sunlight to create energy, and as a byproduct, they released oxygen into the atmosphere. This was a game. The Great Oxidation Event fundamentally transformed our planet, paving the way for more complex life. Around 540 million years ago, something extraordinary happened. The Cambrian explosion. In a relatively short period, life suddenly became incredibly diverse and complex. Life then began its conquest of the land. First plants, then insects, then amphibians. The world turned green. Giant forests grew, which would later become the coal and oil we use today. Dinosaurs came to rule the earth for over 150 million years, an unimaginably long reign. But their time came to a dramatic end 66 million years ago when a massive asteroid struck the planet, causing a mass extinction. This catastrophe, however, opened up new opportunities. With the dinosaurs gone, a small group of survivors, the mammals, began to thrive. They diversified, grew larger, and spread across the globe. Among them were the primates, our distant ancestors. In the savannas of Africa, a particular lineage of apes began to change. They started walking upright on two legs, freeing their hands to make tools. Their brains grew larger and more complex. This was the dawn of humanity. They learned to control fire, to hunt in groups, and to communicate. We were not alone. We shared the planet with other human species like the Neanderthals, but we had a powerful advantage: sophisticated language, art, and symbolic thought. We created cultures. We spread out of Africa, populating every continent on Earth. We survived ice ages, developed agriculture, and built the first cities. We created civilizations, writing, philosophy, and science. We built empires, fought wars, and dreamed of the stars. And that brings us to now. In the grand cosmic calendar, if the entire history of the universe were a single year, all of recorded human history would be just the last few seconds before midnight on December 31st. From the Big Bang to the first stars, from the formation of Earth to the first spark of life.